I'll be repairing the oil leaks on this 2006 Jeep Liberty. The rear seal on the passenger side is leaking, and so is the pinion seal. A variety of tools are needed for this: ratchet, sockets, screwdrivers, rags, drain pan, and plenty of brake cleaner. Also, a large torque wrench and a sensitive dial torque wrench is needed for the pinion yoke reinstallation. A pinion yoke wrench and seal driver are needed too, and of course new seals. Before starting any project, make sure you check your owner's manual or shop manual for the appropriate tools and materials for your own vehicle. This is a little more involved than some common maintenance like oil changes, but not out of the reach of anyone willing to take the time to learn what's involved and do the job correctly and safely. I've set the Jeep on jack stands with the rear wheels removed. Anytime a vehicle is lifted, make sure it's done in a safe manner. Never get under a vehicle held up by a jack. Work safe. Here's the passenger side axle. There's gear lube on the axle, brake caliper, and the wheel. The seal has failed. It's time for a replacement. The caliper needs to come off so the brake rotor can be removed. The two slide pins are removed with a 13mm socket. The caliper is okay, so I'll leave the brake line attached. The caliper is wired to the spring so there isn't stress on the brake line. I'm using some scrap pieces of solid electrical wire, 12 gauge Romex like used in household wiring. It's a lot easier to bend than coat hangers. Off comes the brake rotor, all oily inside and needs cleaning up. The parts need cleaning with brake cleaner to get the oil off. The rotor, including the inside drum portion for the emergency brake shoes, and disc brake pads are cleaned with brake cleaner. Only brake cleaner is used for this. If you can't get them cleaned, they're going to need to be replaced. To change the seal, the axle needs to come out. The axle is held in by a C-lock clip on the inboard end of the axle. So off comes the back cover. A 1/2-inch socket loosens the bolts. I'm leaving one bolt in loose at the top to keep the cover under control when it's popped off to drain the old lube from the differential. Clean out as much of the old fluid as possible. Most differentials, including this one, have a depressed area that will need to be wiped out with a rag or squeegeed with a finger. There should also be a magnet to clean up and reinstall. Make sure the front wheels are chocked and the rear axle on jack stands. The transmission will need to be in neutral to move the ring gear and carrier to access the pins securing the spider gear shaft. And then back in park so the differential doesn't move while working on it. An 8mm socket is used to remove the pin that holds the spider gear shaft in place. The spider shaft keeps the axle from moving inboard. The C-lock keeps it from moving outward. The pin needs to be removed to move the axle in just enough to remove the C-lock. The shaft slides out easily. The axle is pushed in enough so the C-lock is exposed and can be removed with a small magnetic pickup. I don't want the spider gears to fall out, so I'll pull the axle out just enough to reinsert the spider gear pin for now. Everything fits together very easily. Here the spider gear has moved slightly, so it needs to be realigned with the hole in the carrier so the pin goes right back in. Nothing should be forced. Out comes the axle. Here's the old seal. It even looks bad. I'll clean around the seal a bit before popping it out. A rag will keep crud from getting into the bearing and axle tube. The seal can be removed with a small pry bar or a seal puller. I chewed up the old seal a bit pulling it out, but you can see the rubber seal is a little wonky. The mating surface for the seal is wiped clean and any old RTV scraped off. You can feel anything on the machine surface that needs to come off. Or just get down there with a good angle for the bifocals, whatever it takes. I'll put a little bit of RTV on the outside of the seal where it fits in to make sure the seal itself doesn't leak. Then it's tapped in using a hammer and a block of wood. And it's in good all the way around. I'll lube up the seal with some gear lube before putting the axle back in. When putting the axle back in, it's held up a bit so the rough part doesn't drag on the seal on the way in. Before it goes in all the way, I'll put a little more lube on the machine surface where the bearing and the seal go. After it's in most of the way, the inside end is tilted up and moved enough to engage the splines so the axle can be inserted all the way and the C-lock put back on. When the axle is pulled out, the C-lock is captured in the recess. I'll put the pin back in temporarily to make sure the spider gears stay in place. Since I'm into it this far, I'll remove the brake caliper and rotor on the other side and replace that seal too. A little metal protector is needed to free the rotor. A rag keeps crud out of the bearing while I clean around the old seal, and a seal puller pops it right out. If you don't have a block of wood, a seal driver is handy to have. They come in a set with a bunch of sizes and one is just right. I'll take a good close look to see it's in all the way before declaring victory. Whether you use a block of wood or the fancy imported tool, what's important is that the seal is pressed in all the way straight and without damage. Again, the seal is lubed and the axle inserted. Wiggle a little to engage the splines. Lube the machine surface where the bearings and seal run. I'll pull the pin out so the axle goes in far enough to reinstall the C-lock. The axle is pulled back out and the C-lock captured in the recess. The pin goes back in for the final time and the lock pin gets some Loctite and is torqued to the proper spec. In this case, it's 96 inch-pounds. Now for the pinion seal. The pinion is supported by a tapered bearing, so it's a little fussier than the wheel bearing since the pinion nut needs to be installed with the proper preload on the bearing. Make sure you've got a good manual and fully understand what you're getting into before tackling that one. The drive shaft is marked with a paint marker so it can be reassembled in the same position. It's always good practice to put things back like you found them. It's especially critical for spinning parts like the drive shaft, which could be out of balance if reassembled in a different position. A 15mm socket is used to remove the 4 bolts holding the drive shaft to the pinion flange, and then it's wired up out of the way. The drive shaft is off and it's held up out of the way. It came from over here. The pinion nut takes a 1 1/4 inch socket. The pinion is spun 10 times, then checked to see the torque value required to move it. This one takes 8 to 9 inch-pounds to move it. Be consistent. You can influence the reading by how fast you turn the flange with the torque wrench. That value will be used later when it goes back together. Because of the low torque reading, a sensitive torque wrench that starts at 0 is used. This is a dial type with a second needle that marks the highest torque reading attained. These paint marks show where the nut is at before removal and also how the yoke lines up on the splines. This is a yoke wrench used to hold the yoke flange when loosening or tightening the nut. It's got an assortment of slots and holes to attach to the pinion flange and a couple of square holes for a breaker bar. It's a nicely made part. However, in this application, the square holes aren't out far enough and there's interference from the pinion flange and the bolts used to hold it. So the breaker bar goes in the thickness of the plate only. Not good, but I did get the nut off. It's a great idea though and doesn't take up much room in the toolbox. The flange is marked so it can be returned to the same position on the splines. That's probably not critical, but it's a good habit to put things back like you found them. One of those things you're supposed to learn in kindergarten. A puller is used to remove the pinion flange. It comes off easily. As ugly as the pumpkin is, it's full of nicely made precision parts that keep you moving down the road. There's nothing here to go caveman with. Here's the old seal. I'll cover the hole with a rag and clean up the area around the seal. A seal puller is used to remove the pinion seal. Here it is all cleaned up. A flat seal driver won't work here. The shaft is in the way and this seal has an extra lip that sticks out. A short piece of PVC pipe clears the lip and the shaft and works great to install the seal. The seal is lubed before inserting the flange. The seal contact surfaces and splines are greased and the flange reinstalled in the same position from some paint marks added before disassembly. All out of focus or off camera. You know that happens sometimes. The pinion bearing is a tapered bearing that requires preload. This is an area where you would want to check your service manual for the specifics related to your equipment configuration. On this one, Loctite is applied to the nut and then tightened to a minimum spec of 210 foot-pounds. The drag on the pinion is checked and the nut torque increased 5 pounds until the drag on the bearing increased by 10 inch-pounds. In this specific example, 8 inch-pounds before disassembly to 18 inch-pounds. This is kind of tedious. I come up 5 pounds on the nut torque each time, spin the flange a few times, and then check the drag. Okay, we just torqued it to 230. Over and over until the drag increased by 10 inch-pounds, and eventually that was reached with 255 foot-pounds torque on the nut. The values will vary case by case depending on what it takes to increase the turning drag by 10 inch-pounds. Okay, I just torqued it to 235. And now we're going to see what it takes to turn this. Maybe I'll call that 12 or 13. Okay, torque wrench is set to 245. That was 245. We'll check this again. Oh, that's about 17. Okay, torque wrench is set to 250 foot-pounds. Let's see what happens. Okay, I just snugged it up to 250. You can see right now, it's basically back exactly where I started. 255 this time. This has got to be the end. It's got a noticeable amount of drag on it, or I could be getting tired too. That's about 17. We started with 8. That's 17 or 18. I'm going to tend to say it's good where it's at. To recap, before disassembly I checked how much torque it took to turn the spindle. This is with the axles in, but no wheels or rotors installed. The nut was reinstalled and torqued to 210 foot-pounds, the minimum spec in the service manual. I checked the torque to turn the spindle and added 5 pounds to the nut torque until the drag on the spindle increased by 10 inch-pounds. At a nut torque of 255 foot-pounds, the nut was back in about the same spot and the torque to turn the spindle went from a starting point of 8 inch-pounds to 18 inch-pounds. Read your service manual carefully for specifics for setting the preload on your specific equipment. The contact surfaces on the flange mating surface are clean, so there's a good solid fit. I'll put one bolt in for a moment so I don't drop the drive shaft on my head. Mindful of the paint marks so I get it back in the same location. The 4 bolts are installed with Loctite. The bolts are snugged up, then tightened to 85 foot-pounds in a cross pattern. These two then rotate the shaft to tighten the other two. And now rotate to get the other two. The rotors are cleaned up and reinstalled, as well as the calipers. Since it's apart, I'll clean and relube the caliper pins. That's what the caliper slides on. There are grooves at each end for the dust boot to register in. The bolt goes through and holds it all in place. Here you can see how the grooves in the pin capture the dust boot. The brake pads are also lubed where they slide on the clip and there's metal-to-metal contact. After some wiggling, the bolts are back in. The caliper bolts are tightened to 18 foot-pounds. To make it easier to line up the cover plate, I'll make up a couple alignment pins. These are just bolts with the heads cut off and a chamfer cut on the end. I'll also clean up the magnet before putting it back in. It's holding some metallic wear particles, easily removed with a shot of brake cleaner and wiping it off. And then back in the differential housing. Magnet goes in there. Make sure all of the bolt holes are clean and ready for the bolts. The lower holes can hold some old lubricant after draining, which will ooze out and ruin the seal when the bolts are put back in, so it's important to have nice clean bolt holes. The alignment pins will keep the cover plate under control until a few bolts are in. The cover plate is cleaned up before reinstalling. A small round brush works good to get rid of that little bit of sealant that hangs up in the bolt holes. RTV sealant is applied. The alignment pins make it easy to set the cover plate in place and get a few bolts started. Be sure to follow the instructions that come with the RTV. Most of the ones I've worked with will have you bring the bolts up just snug, wait an hour, then torque to spec. Cure times before refilling generally vary from 90 minutes to 24 hours depending on the product. After curing, the bolts are torqued to 30 foot-pounds. AMSOIL Severe Gear 75W-140 provides superior performance and replaces competitors' 75W-140, 80W-140, and 85W-140 gear oils. Use where these viscosities are required by OEMs and where maximum viscosity protection is needed for extreme severe duty applications. The Easy Pack is a real winner too. Just snip and squirt. These are really slick. Full on this is a 1/2 inch below the bottom of the fill hole. Just like that. Looks good. It's been a long one, so if you're still with me, thanks for sticking it out to the end. If you liked the video or find it helpful, be sure to like, share, and hit that subscribe button. Leave a comment if you're so inclined. Check out MidwestSynthetic.com for more information on AMSOIL's line of synthetic lubricants, filters, cleaners, fuel additives, and more. Thanks for watching.